We're given a current. We're told how much current is flowing through this branch right here. It's 30 milliamps. I would like to find out how much current is flowing through the other two branches and the value of the resistor. So applying the same rules, the loop rule and the junction rule, first of all we want to draw the currents flowing through each branch. So we already know how much current is flowing this way. That means the potential difference across this resistor, I times R, is that 12 or 1.2? 30 milli. So I times R. If there's 30 milliamps of current flowing here, it has to turn the corner and flow through that 400 ohm resistor. Okay. Middle branch. I'm going to guess that current's going to flow downwards through the middle branch, going off the tradition that current flows high to low. So let's call this I2. That means the top end of this resistor is going to be higher potential than the lower end of this resistor. By the way, which end of the resistor is higher potential for the 400? Right hand side's higher potential. And then, let's call this I3. That means the left side is higher potential than the right side. Okay. So some rules. Junction rule. We can choose either junction, doesn't really matter. If we choose this top junction, what current is coming towards us?
I3.
I3. So I3 has to equal the currents flowing away from us. That's the I2 and the 30 milliamps. So I2 plus the 0.03 amps. That gives us our junction rule. So I3 has to equal I2 plus 0.03 amps. Questions getting the junction rule? Okay. Loop rules. We need at least two. I am going to suggest doing the outside loop, so going around the perimeter of the whole thing. That way we're going to miss that unknown resistor. Well, we're going to have to go through the middle resistor in order to find out what the resistance is. But for right now, let's skip it. You can start wherever you want. Start in the top right-hand corner and go down. As we come down, we're going to pass this battery. Is it a gain or a drop? Gain of 10 volts. Keep going through. Ammeters have negligible resistance, so we don't need to worry about it. As we go past this 400 ohm resistor to the left, gain or a drop? Drop. Positive to negative, that's the direction we're going. The voltage is the current that's flowing through it, which is 30 milliamps, times its resistance, which is 400 ohms, which we already figured out was 1.2 volts. Keep going. Next thing we come to is this 30 volt battery. We're going from the negative to positive end. So we're going to see a gain of 30 volts. Next thing we come to is our resistor. We're going positive to negative. So we're going to see a drop of its voltage. Its voltage depends upon the current I3 and its resistance, which is 500 ohms. That gets us back to where we started. So that all has to equal 0. Which, conveniently enough, the only unknown we have is I3. So we have, what, 40 minus 1.2 is what, 38.8? Taking this to the other side, we find that I3 is 38.8 divided by 500. Is that right?
77.6 million.
Okay, that's why. I'm a little retarded. It's 12, not 1.2. So 10 minus 12 would be negative 2, so we get 28 volts. So 28 divided by 500.
56 million.
Yep. So either way, you can write it as in milliamps or regular amps. Doesn't matter. Coming back to our equation up here, we now know I3. I2 is going to be I3 minus the 0.03. So 0.026 amps. It's always nice when we're given a current. Always makes at least one of the equations really simple. Minimizes the algebra. So we now know all of the current. We were given the 30 milliamps. We now know I2 and I3 as well. Since we got positive answers for both of them, that means we drew them in the correct direction. That is the direction they're flowing. Now to find the resistance. To find the resistance, R, what this resistor value is, we need to do either the right-hand loop or the left-hand loop. Doesn't matter which one. If we do the right-hand loop, let's start in the same place and go down again, but this time we're going to come up through the middle. So we still see a gain of 10 volts. We still see a drop of 12 volts. So 10 volts from the battery, a drop of 12 volts from this resistor. Going up through the middle, we're going negative to positive, so we're going to see a gain. Its voltage depends upon I2 and its resistance R. Keep going up, we're going through the battery, we're going positive to negative, so we're going to see a drop of 15 volts. That gets us back to where we started, so that all has to equal 0. So I2R has to equal, bringing all this to the other side, get what, negative 5, negative 17. So 17 volts on this side. We know I2. We already figured it out, which, there we go. I2 is 0.026 amps. So 17 divided by 0.026, 654 ohms is the resistance of that particular resistor.
This isn't that bad.
It's not too bad, no. Takes a little practice through a few of them, but it isn't too bad to do. This is an example of one that matrices wouldn't have worked for. Okay, not knowing R would have filled up your matrix.
Well, you just need to know when and when not to use the matrix.
Oh, exactly.
I mean, if you've got, yeah, the top two, you would have had two unknowns, so you could have done it.
Oh, certainly, yeah, definitely.
Two.
It's always nice when you're given a current. Just keep that in mind. If they give you a current, then some of your equations are going to be really easy. They're going to work out really nice. Okay. Any questions on how we got any of the equations?
It's a matter of remembering it.
Yeah. So the process is drawing in your currents, figure out high and low for your resistors, and then write some equations. Write out your junction rule, write out a couple loop rules. If you're given current and you've written a couple loop rules and none of them are easy yet, write the third one. Okay, because if you're given a current, one of the loop rules is going to be nice. One will give you only one unknown, like this one did.